All right, now we're going to talk about inverse functions and how to find the inverse function just from a graph. And also, we're going to identify whether the inverse, whether or not it has an inverse function, just based on the graph. So once we start going into it, you'll see what I'm talking about. So if we have a function here, and we'll draw this up. This is a function, a quadratic function, 2x squared plus 2x plus 2. No, for no reason, just wanted to draw a quadratic on here. Now, if you remember, we had the vertical line test that would be able to, we could use to see if something, if a relation was an actual function or not. Excuse me. So if we've got, and that was the vertical line test. So if we draw a vertical line and it only intersects our relationship at one point, then that's a function. So I mean, as you can see right now, this is a function. But we're talking about inverses, and we want to find what the inverse of this function is and whether or not it actually has an inverse. Well, for the graph of an inverse, the inverse function is reflected around this line here, the line of the unity line, where x equals y. You've got a line there that with a slope of 1, where whatever x is, that's also what y equals. Now, when I say reflected around this axis, it means if you can imagine folding this graph along this line, then you would see that the inverse is going to be the exact same of this function, just reflected around this line. And I'll make that visible here, and you'll see that inverse. So this is the inverse of our function, our original function. And as you can see, or you should be able to see, this inverse is not a function because we draw a vertical line and it intersects at 2 points. So x could be, when x is 4, y could be 0.618, or it could be negative 1.618. And that's true anywhere along the line. So if we draw a vertical line, it's going to intersect at 2 points. So that is not a function. Now, we would have been able to tell that earlier without even drawing this out, because we can use a horizontal line test on our original function to see if it's going to have an inverse function. So if we draw a horizontal line through a function, through a graph, and it intersects at more than one place, then it stands to reason if you reflect it around this line, then that vertical line is going to intercept at 2 places. So since this is not a function, if we draw a horizontal line through our original function, that means it's not going to have an inverse function, because the inverse will not have a one-to-one relationship. So we can use a horizontal line test, draw a horizontal line through a function to see if it's going to have an inverse. So we can do the same thing with a different function here. I'm going to leave my unity line up here. But suppose we have an exponential function. We've got y equals 2x here. So we can see we'll draw a vertical line. We'll actually intercept it here, kind of prove my point. So we'll draw a vertical line, and to show that this is a function, because it only intercepts at 1 point. But we can use our horizontal line test to see that the inverse is also going to be a function, because it's only intercepting at this one location here. So we draw a horizontal line through the function. The inverse will also have will also be a function. So we'll reflect it around this line of unity, y equals x, and that's what the inverse function looks like. Now, if for some reason revolving it around this line of unity is just too confusing, remember that when you're taking the inverse, what you're doing is you're swapping the x's and the y's. So you could actually do that for the graph. I mean, if you've got this original graph, y equals 2x, and so you've got the point x is 0, y equals 1. Well, at the inverse, you would just swap those positions. So x is 1 and y is 0. Here on our original graph, x is 2, y equals 4. You swap those around on the inverse, x is 4, y equals 2. So you do that a few times, and then you can just easily graph your inverse function if for some reason it's too hard to visualize, just reflecting it around this the line y equals x. So that's all you have to do for looking at a graph and seeing if it has an inverse function, and also just a brief overview of how you would create an inverse graph based on the original graph.